Okay, so we're talking now about a factorial design. I've introduced you to it many times, but this time you finally got to learn the details of what the factorial was. And the lecture took you through all the components and a few different examples. So let's just discuss what is the difference maybe between a between groups and a within subjects design. So between groups factor is one in which what? Groups are independent. Yes. What else could you say about a between factor or between groups design? So subjects are in one level of the factor, or we might say one group. Yeah. Okay, so what is a within subjects factor? How's that different from a between groups? Yes. So subjects are in all levels of the factor. Good. Then whenever you see this naming system over here, when you say one way or two way, what does that imply to you?
Multiple independent variables, so there's two levels, or two ways is going to be multiple independent variables, one way is going to be one independent variable.
Good. So that indicates to you the number of independent variables or factors. Independent variables or factors. So when we talk about factorial designs, which one of these are factorial designs? Which is it? The two-way, yeah. So these that have more than one factor or independent variables are called factorials in terms of their design. They don't have a single factor, they have more than one factor. So the completely randomized factorial is which one of these listed up here?
Two-way between.
Two-way between. So specifically, this one is the completely randomized factorial. Completely randomized factorial. What do you think you would call this two-way within subjects? Yeah, a repeated measures factorial design. Good. So the one way within was our repeated measure, but when we have multiple within subjects factors, it's a repeated measures factorial. So this one between, one within, you might call this one a mixed design because it's a mixture of between and within. And that's what we're going to talk about next week. Specifically, this one is a split plot factorial, where one of the factors is a between groups and one of the factors is a within subjects. So it gets more complicated as we go on and we add different combinations of our variables. Today, though, we're just talking about the completely randomized factorial design. So what are the conditions of the variables? Sorry about that. What are the conditions of the variables for a completely randomized factorial?
It's used when there are two treatments or factors.
Good. So two treatments or factors.
Is greater than or equal to 2 levels for each treatment.
So each has 2 or more levels.
Experimental units are randomly assigned to one of the A and B treatment combinations.
Good. So each subject is in one of the A-B treatment combinations. So that implies that factor A and factor B are both between or within. So each has 2 or more levels. These 2 treatment factors are both between groups factors. And what do we know about the dependent variable? It's continuous. So we have one dependent variable that is continuous. Good. Okay, so here we have the model equation, some components we've seen before, some are new. What is the mu that we see here? Grand mean, it's always been the grand mean. And what about alpha? Treatment A effect. Now, since we have another treatment, which we call treatment B, we have beta, which is treatment B effect. And then what do we call this one here, this alpha beta? Interaction effect. We finally get to learn about the interaction. And then epsilon is, as it's been before, just the error effect. So up here, when we are trying to understand what is mu in terms of the grand mean, so this is the table that we saw last time, where we have treatment A, which is the format of the test, and treatment B, which is gender, male or female. What up here quantifies the grand mean? The y bar dot dot dot. Good. What up here is the alpha or treatment A effect? Good. When we compare the treatment A means, so y bar dot 1 dot and dot 2 dot. What is the treatment B effect?
Y bar dot dot 1 and dot dot 2.
Good. When we compare group means collapsed over the other factor. So here, these are our beta effects. And where do we see the interaction? On the inside, yes. So what does this mean represent? This is the mean of subjects in which level of treatment A? Paper. And which level of gender? Male. So if we compare these inside interaction means or treatment combination means, then we can detect if there is an interaction. Good. So the partitioning of our sums of squares, it's similar to the ANOVA in that we are separating our between and our within variability. But since we have multiple treatments, we need to be able to detect the treatments individually and that interaction. So we take the sums of squares between and further partition it into each of the treatment effects and the interaction. We first test the interaction anytime we do any type of factorial design. So this is not just true of a completely randomized factorial. This is the process that you would go through for any type of factorial design. So if the interaction is not significant, what do you look at next? Main effects. Main effect of A and main effect of B. And if the interaction is significant, P less than 0.05, what do you look at? Simple main effects. So we look at the simple main effect of factor A within each level of B and the simple main effects of B within each level of A. Good. So what is the first hypothesis that we evaluate for this factorial design? And this is the one that we're going to call the omnibus F.
O, H, O. What's wrong?
The interaction equals 0.
Yes, okay, we'll write it in words. The interaction effect or the alpha beta effect equals 0. It also kind of, if I'm writing it out in words, it says that all of the interaction or treatment combo means are equal. So if I look back at what those interaction means are, it would say that these internal subgroup of A and B, those four means are all equal in this 2x2 design. Good. So can you describe for me what is an interaction?
Interaction implies that the effects at a specific level of treatment A across levels of treatment B are different than the effects at another level of treatment A across the levels of treatment B.
Good. Okay, that was in words. It implies that the effects of one level of treatment A across all levels of treatment B is different at a different level of treatment A across those levels of B. What does it look like on a plot?
So if there's no interaction, it will be perfectly parallel. Okay,
so a no interaction implies that, let's see, this will be A1 and A level 2, okay? And we'll say that B1 and B2, B1 at A1 and A2, and then B2 at A1 and A2. So the effects that we see at A1 is the same at both levels of B. Whether we're looking vertically or we're looking horizontally, there's the same shift across all levels of A and all levels of B. Yeah. So what does a plot look like that does have an interaction? The lines will not have the same slope, or they won't be parallel. So now let me write this out. What is an interaction? An interaction is when the effect of treatment of a single level of treatment A across levels of B is different than the effects of another level of treatment A across levels of B. So you said an interaction is detected when lines are not parallel. So I hear break down the interaction as ordinal and disordinal. Which one of these has non-parallel lines that intersect each other? Disordinal, okay. So over here, A1, A2, my lines would look like this. So B1 starts low at A1 and increases at A2, but B2 starts high at A1 and decreases lower at A2. So the difference is a disordinal interaction, the lines cross. And in an ordinal interaction, what happens? They aren't parallel, but they don't necessarily cross like that. So it might just be a similar pattern, but not quite to the extent. So here we have B1 and maybe B2. So B1 increases and B2 decreases, but they don't flip in their ordering of which one is always higher. So in the ordinal interaction, we could draw a line here and say that B2 is always greater than B1, but the degree to which it's different changes. But over here, they completely flip, and at one place, B1 is higher than B2, and at the other, B2 is higher than B1. The ordinal lines don't cross.
Does that hold true if we had 3 or 4 levels of A?
Yes.
Okay.
Uh-huh.
That ordinal would never cross.
Yeah.
Okay.
Other questions? Okay, so when we do not have an interaction, what did you say was the next test? Main effects. And main effects are kind of like two separate one-way ANOVAs. You are looking at each of the factors distinctly, not as it relates to any level of the other variable. So you collapse across all levels of the other. So what does it mean that the factorial has only an A factor main effect?
The means across levels of treatment A differ into the same degree for all levels of treatment.
Good. So I understand these a lot better in a graph. That's why I always include the graph. So if we only have an A main effect, then if I'm just looking at factor A, is A1 different than A2? Yeah. The mean at A1 is 1. The mean at A2 is 2. And 1 does not equal 2, right? Yeah. So we see an A main effect there. Is there a B main effect? Meaning here we have, let's see, the red is B2 and the blue is B1. Does B1 and B2 differ here? No. Does it differ here? No, so B1 and B2 are the same, so there's not a B main effect. Now, what does it mean that we have only a B main effect? So if I look at A1, is A1 different from A2?
No.
Nope, not at either level. And if we think about kind of averaging those, it would be the same across both. But does B1 and B2 differ from each other? Yeah, so here we see the not equal. So the A's don't change, but the B's do, and that implies the B main effect. The last one is where we have both an A main effect and a B main effect. So both of these factors are changing at the different levels. A1 is different from A2, and B1 is different from B2, but the changes that we see in each of those are the same at all levels of the other factor. Okay, so the change that we see from A1 to A2 is the same in B1 and B2. And the change that we see in B1 is the same at A1 and A2. Okay. So rather than write it out in words, to me it makes more sense in the visual. Okay. And I say it, I feel like 5 different ways on the first lecture. But it's kind of hard to understand if we are just kind of starting out. So I wanted to talk about that again. When treatments do have an interaction, you said that simple main effects were studied. And some might call these just simple effects, where you have a main effect and a simple effect. When I started teaching this, the books that I used, most of them use simple main, so that's why I use it here. But in literature, you might just see simple effect. So if we say that factor A is format and factor B is gender, describe the simple main effect of factor A, paper.
Females prefer paper tests or did better on paper tests.
Good. Okay, so when we talk about the simple main effect of A, we have to say at B1, or male, and then at B2, female. So for males, the paper was low, and for females, it was high. And then to describe the simple main effect of factor B, it is electronic. So notice whenever you said it right, because whenever you talked about the simple main effect of factor A, you talked about specifically within male and then specifically within female. So we would say male, let me finish this out. When we're talking about factor A as a whole, this is format. Okay? So the format for the male is low for paper and high for electronics. So I'm going to finish this out. Low paper, high electronic. And what do we put for female? There we go. High paper, low electronic. So we almost have to see all levels of both factors described in the simple main effects. And it should be confusing because that's what simple main effects are, kind of at the lowest level of all of them. So you have a lot of levels of both factors. Yeah. So to describe the simple effects of B, which is gender, we have to talk about both male and female at A1, which is paper, and at A2, which is electronic. So what would you say for the paper test only?
High female, low male.
High female, low male. And what would you say about electronic?
High male, low female.
High male, low female.
Does that matter if you do the factor A1 first or the high or low first?
Not really. So how many levels of factor A did we have? A had 2 levels. And how many levels of B? 2. So when we look at simple main effects, we should have 4. 2 by 2 equals 4 simple main effects. Yes. Do you understand the difference between a main effect and a simple main effect? Pretty good. Okay. So here, describe some, it's looking at the same thing, but now we're using different terms. So instead of using the model equation components, we're using the actual effects here. So what is the interaction effect?
Red ones.
The red ones. So the interaction effect would compare the format, both formats at both levels of gender. So all of formats and all of genders. So every level of everything all at the same time. Okay, what would describe the potential main effects? The green and the purple. So here is the main effect of format, and here is the main effect of gender. One for each of the factors. And then what would the simple main effects be?
Same.
The simple main is like the males 1 and 2.
Good.
Red, but
Good. So this comparison right here would be the simple main effect of
it's of the format.
Because format is changing, paper or electronic, for males only. And then this comparison here is a simple main effect of format on only female. Good. For female. Any more? Yeah. So this one, this comparison is the simple main effect of gender, because gender is what is different on those two means for paper, because both of them are specific to paper. Good. And then here, simple main effect of gender again for electronic. Good. Very good. What are the assumptions for the completely randomized factorial? Normally distributed data. Data are independent and homogeneity of variance. So the same as a one-way, but now it's just kind of at that interaction level. So within each treatment combo, normally distributed data across those different treatment combinations. We have equal variances, and then independence within and across the different groups. Yeah. Okay, so then we stepped into another example, and I showed you in SPSS. First one was the popcorn example where we had brand and cook time. So here, describe the interaction between brand and cook time.
It's ordinal.
Okay.
Small interaction.
Okay. How do you know that?
I copied the graph from the.
That's okay. How can we notice that it's an ordinal interaction by what we see up here?
Well, it looks like, so for the B, for the generic, the numbers are higher than the interactions for the name group.
Good. So the group means on the generic at each level of time is always higher for the generic group than it is for the name brand group. Very good. And likewise, we could see here within generic, we increase and we increase, but here we increase and then we decrease, which indicates to us that there is an interaction because we don't see that same trend throughout the whole thing. Yeah. What about the main effect of brand? Yes, so we'll call those on the outside, they're marginal means. So a main effect is noted by a marginal mean comparing the overall generic and name brands. And what about the main effect of cook time? Marginals along the bottom. Oops, here. Nope, that was right. So here the overall mean of 105 seconds, 120, and 135 seconds. Yes. And then what about the simple main effect of first brand within cook time? So here brand changes and cook time stays the same. Brand and cook time, brand and cook time. And then what about the simple effect of cook time within each brand? Horizontal. So here, time changes specifically within generic, and then time changes specifically within the name brand. Good. You did some of this by hand and calculated sums of squares, degrees of freedom, mean square, and the F. And which one of these is the error term? The last one, the residual error. But I just note that because all of these F statistics have the same denominator. That's the only thing that's changing when we calculate those different F statistics. And what is evaluated first? The interaction. And we see a really small F statistic. So was that significant or not significant? Not significant. And what was evaluated next? Main effects, which we can get directly from that same ANOVA table. So main effects of treatment and main effect of time. So if we don't have an interaction, we have all that we need and we don't have to do anything else. In the SPSS files for completely randomized factorial, it's just that we're adding another column to the one-way ANOVA. So we should have a factor, I think this is factor A, and we have a column for factor B, and then we have a column for the dependent variable. So back to those horizontals. Remember, repeated measures, our data were clean and horizontal, but here we have those columns again. I'll go through the SPSS here in a bit, but then you have measures of association, and now we can have an overall total measure of association. And here, how do you, what does this notation mean? Where we have a Y bar A, Y bar B, Y bar AB. Good. So this is the association of treatment A with the dependent variable, of treatment B with the dependent variable, and of treatment interaction, AB, with the dependent variable. And so the only thing that's really changing is the numerator, and the denominator has all four components of the model in it. And for the sigma squareds that you see, we have these equations that we can pull stuff from our ANOVA table in terms of mean squares. These partial omega squareds are the association of the different components when we ignore the other parts. Because we can do that, because we know what effect and variability factor B has. So we can control for that whenever we really want to know the isolated effect of treatment A. So here we have the effect of A on the dependent variable when we control for B and AB. And how do we see that in our equation over there? The dot, So dot, these are excluded from the denominator, right? So over here, this is omega squared for treatment A, and we see treatment A on the top and all four components on the bottom. This one is the corresponding partial omega squared, where it's still the association of A with the dependent variable, but now we are controlling or ignoring the effect of treatment B and the interaction. And then we can do that also for B and for AB. And the effect size is the same as it always has been and always will be in terms of this F, where we take the square root of the effect size, measure of association, divided by 1 minus that same measure of association. And the same criterion still hold as well. Power, we can utilize G-star power, so it now has an F for a 2 between, I'm not sure exactly what it calls it on there, but we can look it up. Okay. Then the next part of the lecture was example number 2, a response to intervention groups and gender. So we could go through, I feel like you have a good understanding of interactions, mains, and simple main effects. You okay on that? Okay. So then we first tested the interaction using SPSS, and what did we find? It is significant. So the next step is to look at what? The simple main effects. And do we get that anywhere by default or through clicking in SPSS? No, unfortunately we do not. So we have to go back into your SPSS, pull up your univariate, and then click on the options. Options brings up that additional window, and we put all of the components in this display means for box. We want to compare main effects, and then the Bonferroni. So it's similar to how you got the complete contrast in the repeated measures where you had to put it over there and then compare main effects, et cetera, et cetera. And now, whenever you do that and you continue, you click on the paste instead of directly OK. It doesn't know, well, it knows what to do with that if you just click OK, but we want to change it up just a little bit. And one day, I'm expecting soon, there will be, you know, simple main effect checkmark box, and it just gives it to them. I don't know why that's not there yet. So whenever we get that, we have some things up here, but I explained to you how to modify this box so that you have the EM means for, and we want gender, and we could delete this one for the interaction. And these two lines here give us the simple main effects that we want. And the simple main effects, did y'all do this in SPSS? Yeah. So it gives you output. Honestly, it gives it to you backwards. So whenever you get the simple main effects, you'll get the simple main effects for gender, and then you'll get the simple main effects for the intervention. Each of those will give you 3 different tables, and you go to the last one first, which is titled univariate test, and it says simple main effect of gender. So this is gender within the 18 weeks, within the 9 weeks, and within the 0 weeks. And in order to control the overall type 1 error rate, how should we evaluate those? If we want to maintain a 0.05 family-wise error rate, we evaluate these at alpha equal 0.05 divided by how many tests am I doing? 3. So we would evaluate them all at that modified level of significance. Here are the univariate simple effects of the intervention. So this is the intervention at female, and then specifically at male. And again, modify your alpha 0.05 over how many in this case? 2 tests for this one. Yep. And so this one, the intervention had 3 levels, 0, 9, and 18. So when we see that this one is significant, this says at least 1 level of intervention is different within male. But there are 3 levels, right? So we have the overall interaction, and now we have simple main effects. And if the simple main effect is significant, then it's kind of like that final post hoc of specifically which one is different. And that output, you give it, or it gives it to you by default. It's called the pairwise comparison. So here, this is the simple main effect of intervention within female, and then the simple main effect of intervention within male. And that's where we kind of get that lowest level of where are my differences, okay? The last thing that the lecture talked about was unequal sample sizes. There was a pretty good discussion about why do we have the unequal sample sizes? Was it by design, nutrition? Maybe it couldn't have been helped. But ANOVA has ways, and SPSS has ways of dealing with that. It's pretty simple in your part in terms of selecting a different option. But the mathematics behind it, I don't go into that because I feel like that's not really part of this class. Maybe if you took this over in the stat department, they would spend a lot of time on these different types of sums of squares. You might have to calculate them all different ways and things like that. But I'm comfortable with just explaining them and when to use them in this class. In SPSS, that option is in the model at the very bottom, what type of sums of squares. And type 3 is the default and the most often used. Okay. Any other questions about the completely randomized factorial design? All of homework 5 is specific to the completely randomized factorial. So you should be able to do that. Now I have another example that I want us to go through in SPSS together, step by step, because it has to do with those simple main effects and typing all that in, and I want to make sure that we understand that. So in your bright space today, I uploaded a new data set, and it is called the drug trial data. So go ahead and open up the drug trial data. And when you have it open, raise your hand. Okay. I know SPSS takes a little bit. Okay. Okay, so the first thing that we do with this is testing normality. How do we test for normality for this data? Analyze, descriptives, explore, and maybe I should tell you about the data just a little bit. So we had 24 males and 24 females taking part in this study. Half of the females were assigned to either a low or a high dose of a drug, and then half of the males were assigned to the low or the high dose of the drug. And then after a week of being on the drug, the participants were then tested, okay? So in your data, which of those is the dependent variable? Test score, and what is the factor? Say it again. Gender and dose. Very good. And then we get our normality through the plot. Continue and okay. And then on the left, you'll notice that it gives us the analysis for gender, and then it gives us the analysis specific for dose. So I'll go to test of normality. Are the data within gender groups normally distributed? Yeah, they're both above 0.05. And what about the test of normality within the dosage groups? Good. So everybody shakes their head no. We see that the high group is not normally distributed. So do we need a modification for this? Not yet based on this, because we have equal sample sizes, which is a benefit of having equal sample sizes. So you might say, why do we even test it if it doesn't matter if we have equal sample sizes? But it's good to do, as you've been reading in those articles. It's nice whenever you know that the researcher at least looked at it regardless of if it was necessary. So then we'll go in and get the other test of assumption for equal variances and the output. So how do we do the factorial design here? Analyze general linear model and univariate. Good. Which one do I put in the dependent variable? Test score. And are gender and dosage fixed or random factors? Fixed. Very good. I would like the plots because to me, I like to be able to visualize if there's an interaction. So for the plot, I'll put gender horizontal and dose to separate and click add. And then I'll do it the other way too, because sometimes if we look at it from a different perspective, we might notice something that we wouldn't have otherwise noticed. And continue. And because this is the first time we're looking at the data, why don't we give ourselves descriptive statistics and those homogeneity tests. I'll click continue and then click OK. So did everybody get that output? You should have between subjects factors, descriptives, Levine's, between, and then these two plots here. Good? Okay. Something that I don't think I've ever really spent time on talking about, but I want to do that because as we include more factors, it gets more complicated. But if we look at that table of descriptive statistics, I just copied it into this PowerPoint. And this is kind of the format that I like to look at things in terms of what's a main effect, what's an interaction. And so can we pull values from the descriptive statistics and put them over here? I just want to do that just so I know we did it once in class, okay? So what is the low dose male? 4.58. What is the male high dose? 7.08. And what is the overall male mean?
5.833.
Good, 5.833. Now for the female, what is the average of the low dose? 2.92. And what about the high dose? 2.50. And what about overall female?
0.71.
And then what about the overall low dose mean? And the overall high dose mean? And grand mean. Good. So if we just talked about this, I know we would start first with an interaction, but the most simple way to look at this is as two main effects, okay? So does it look like males and females differ in this study? Yeah. So we see overall that male is higher than female, and even within both of these, male is higher. What about the effects of low and high dose? Which one is always a bigger value? High dose overall. Is the high dose high in females? No, actually. So overall, the high dose had the largest score, but within female, the low dose had a higher score, and for the male, the high dose had a higher score. So what does that clue you into? The males may be more affected because the magnitude of these values is different.
Well, it's not even magnitude, the direction of them is different.
The direction of them is also different, yeah. So what word does that imply? Disordinal interaction. Very good. If we looked at the plots, I didn't put them on this, but we get them in SPSS. Let's see if that lines up with what we think. Does that look like a disordinal interaction? It does from that one. Do I see it here? No. So when I look at this from different perspectives, from one way it looks ordinal, from one way it looks disordinal. Is that important? Not necessarily, but it does help us. We observed that the female was always lower than the male, but we saw that change when we looked at it from the other view.
So how are those graphs different then?
Yeah, that's what I'm asking. Thank you.
What do you mean by different?
So the top one looks at the.
Let me put it over here. It is the same information. Okay.
Okay, so when I look at the side, when I look at the far left, the estimated mean, so that's just telling me the mean of the drug dose, right?
Mm-hmm.
And so is it because it's showing me an actual value as opposed to putting them, like, I don't understand how the low and high, I don't understand how they both don't cross.
Okay.
Like, the one crosses I feel like the other one should, but.
Is it because the gender it crosses, and then on the dosage it doesn't? So that just means that the means of the two are equal?
I wanted to just, my mind just got it.
Yay! Explain it.
Okay, because the points are not the same idea. So on the one on the left, points are representing the drug dosage for the low and high drug dosage and where they go for male and female, versus on the other side, the points represent the gender, the difference in gender on low and high.
Very good.
Yeah.
Mm-hmm.
So it just gives us a different perspective.
So if you look, the points are all on the same like.
We could match them up.
Yeah, that way. It's just where they are on what they're being put on the.
How they're separated.
Mhm.
Yes.
So this is what they call qualitative research, and they're looking at different lenses.
Yes, we are looking at this through different lenses. Mm-hmm. Dr. Bailey or Dr. Bindewald may be happy to know that we incorporated qualitative research in our stuff today.
Well, and you can even do like on the low to high.
Mm-hmm.
On this one, you could even draw in the lines from corners. The corners essentially are the same one on that side, so you can see the interaction there. Because you have the female low to the female high, right?
Mm-hmm. Yep. And here we see the low to the high. Uh-huh. And here, male low to high, we see a big jump, and here we see male low to high. So they are giving us same information, but it's through a different lens, through a different perspective. And sometimes it's good to look at things from different perspectives. Is it really important for this class that one is ordinal and one is disordinal? Not necessarily, but it just kind of helps us to tell that story a little bit better and make sure that we're not excluding something whenever we go to phrase it or describe it.
Did you basically just graph the simple main effects?
Yes. Mm-hmm. Yeah, so these are graphs. Right. Mm-hmm. So this could be the simple main effect of gender within each level of dose, and then the simple main effect of dose within level of gender. Yeah.
You don't get that from a video.
Do what?
I said you don't get that from a video.
Really? Okay. Good. I'm glad we talked about it. It's hard. Sometimes I feel like I say the same thing the same way every time, and every once in a while it'll come out different and it'll click. Okay, so we can tell a story, but we haven't really tested anything significantly. And that is where we go to Levine's test for the second assumption that we need to look at. And does Levine's test hold? Yes. Now we can go to the between subjects effects, which I've copied over into the PowerPoint here. Where do we look first on this between subjects effects table? The interaction, the gender by dose, even though we're very, very tempted to look at the effect of gender or the effect of dose. We can't do that yet. And based on this, is the interaction significant or not? Yeah. It is significant. How do I write the F statistic for that interaction? 1 and 44 equals 13.736. It was, I finally got through your article reviews, and a few people actually pulled Oklahoma State faculty, which is kind of fun because you recognize them. You might be related. Not related in family, but
Yeah.
related to the person. You know who they are. But so it was interesting how y'all noted that they didn't write the F statistic right or different things. And so you could, instead of just being a consumer of those articles, now you can kind of critique them a little bit too, which is interesting. And I like to see that. So here we would say P is what to 0.05? Less than. What did y'all say?
She said critique Dr. Edwards to be the reverse.
Oh, so maybe it's not that great to critique your own advisor, maybe.
When you get papers back from Dr. Edwards, they weigh twice as much because there's that much ink on them.
Oh, nice. Yeah.
Bring one in the chair.
Okay, please do. I had one of my faculty members on my committee did old school, you know, on the paper with red ink, and I got that back and thought, oh my, this is not good. But I learned to appreciate it and then liked it because nobody had ever told me a lot of the things and mistakes that I had made. So when you have somebody that takes the time to read every single word and where you have a period or a space, or I appreciated that, even though you had to swallow the humble pill a little bit.
So then you can do the difference between one space and two space after a period.
Yes. Mm-hmm.
Okay.
Do y'all know that in Word you can click on the little box that will show you the spaces with a dot?
Yeah.
So you, okay.
You can also do find and replace.
Find and replace is your best friend.
All day long.
Yeah. Okay, so since the interaction is significant, what do we do next? Simple main effects. Do we get that anywhere on this output?
Of course not.
Do we get that here? No. So we'll have to go into our SPSS again and click on the options and then make this modification down here. So let's do that together so I make sure that you know how to do it. Analyze general linear model and univariate. It's all still in there. Now options, and we'll put these three different components into the display means for. Compare main effects, and then Bonferroni adjustment. Click continue, and then instead of clicking OK, click paste.
Paste?
Mm-hmm. Okay, did you get that output? Okay. let me look at something in my notes because I was playing around with this earlier today. I want to verify. Okay, so we want the compare adjust Bonferroni I'm going to experiment for just a second. I'm going to see what happens if I don't do all of that. Okay. So yeah, that doesn't work. Okay. So sorry about that. We want to compare the adjust Bonferroni. We want all of that next to the interaction. And then next to compare, we want to compare the interaction within gender. And then we can copy that and paste it. And do the same thing for dose. I think I don't need to capitalize. Let's see. Can I zoom in?
I don't think you can on that photo.
Oh, there we go. Okay. So you really want that line that says EM means with the interaction. But next to that, you need the compare and the Bonferroni. And then next to compare, we want to compare specifically on gender and then specifically on dose. Nope, we don't need just gender or just dose. The main thing, it depends how many lines you have because I still have my plot in there, which you don't necessarily need. And I still have my print for the descriptives and the homogeneity that we don't actually need. So we could delete some of those things. But the main components are these two EM means lines. Do we get those? Raise your hand if you're good. Okay. Now you can highlight all of that and click on the green run selection. Yeah. This one? Okay. So you should get some output that at the very bottom you have these univariate test tables that say simple main effects under them. Okay, so take the compare, adjust Bonferroni, select that. And copy it. And then put it down on that line where the interaction is. And then next to compare, put your cursor by the compare. In parentheses, gender. Okay. And then you want to copy that line. All of it. All of it. Good. So put your cursor after one for me. And close that parentheses. Oh, enter first. And instead of gender on the second, we want now you can delete the first two and mean one. All of it, huh? So you only have those two E and mean one. And then you might have to select it, but otherwise just one. Let's go back into your syntax. So you have to look at maybe there's a there you go. Good. You got it. Okay, so on the left-hand side, you see that you have these estimated marginal means, and you have gender, and then you have gender. So the first one, remember I told you it gives you this information backwards. So the first thing is the univariate test. That's what your first interest is. Let me copy and put it here. So we have our univariate test for gender.
First gender and second.
Mm-hmm. Yep. And then I'm going to go down and get my univariate test for dose. I'm just going to copy it into my slide so I can then talk about it. Okay, so this is the first set of output that you get. And this says it's the simple effect of gender within each level of dose. So this is female versus male within the low group. And then this is female versus male within the high group. And since I have two tests that I'm doing, we're going to do each of them at an alpha 0.05 divided by 2 or 0.025. So do males and females differ significantly for the low dose? Yes. Do males and females differ for the high group? Yes. Now, since there's just two levels, it's kind of like, do we need to know if at least one group mean is different? We don't really need to go on further. So this should just align because we have two groups. So the second one isn't as useful. When we want to know which one is higher and which one is lower, we can go back and look at our groups. We remember that males were higher on all of them. So we could say that males are significantly higher than females in the low dose group, and males are significantly higher than females in the high dose group. But the difference and the magnitude of the difference, so if we did the effect sizes, they would be different. The second one is the simple effect of drug dose within male and female. So this is high-low within male and high-low within female. Again, we could test them at an alpha 0.025. And do males differ significantly at high-low? Yeah. Do females? No. And remember on the plot, those dots were really close to each other? So everything is different in those 2x2 groups except the female across the two different dosages. So factorials are all about this process. We first do the interaction that leads us to main or simple main, and then each of those leads to post hoc tests if necessary. But it's really important to follow that. And when you read about factorials, we read about a few of them in the repeated measures. They did like a 2 within. And if you go back and read them, you'll notice they don't always test for the interaction, which could be problematic. Because here, if I didn't test for the interaction, I don't know about this, would we say that males and females differ in their dosage? Yeah. Oh. Yeah. Would we say that low and high dosage are different? Yeah. But we wouldn't, what would we miss if we just looked at that? Yeah, the females actually aren't different in the dosage. It's just that the male are, and they're so wide that it's significant here. Yeah. So it's really important if the interaction is significant to first test that and then look within those simple effects. Good. Any other questions? Ooh. Oh, good. Very good. Okay, so I have 2 articles. We'll just split y'all up into different groups. So let's see, 2. You can get into groups of 2s, and one group will be a group of 3. And I'll just give you one article about this one. You can just take some time and together go through this article. Okay, y'all.
We have a copy. So we have 2 and 3 and 1.
Okay.
You know, girl, you gotta make something.
I think he was hiding behind the
Okay, let's do that one. Okay. Yes, if you need to take a break, feel free.
Longest titles in history of man.
Sure.
Effort.
Gender, teamwork, orientation.
What is our journal?
A journal of advanced activities. That is a scary. Education.
Oh, yeah. Behavior.
And then I Googled really quick, how do you go back to the beginning slide? That's the home key, which I learned today. So go to the first one and then key goes to the end. And I should have ordered this to get key on your PowerPoint, it's black. Alright, girl in the dance I've known is years, 2000.
Yeah. I don't know if we got this far.
Oh, I'm so sorry.
No, I'm doing it all by myself. Team of three and then just. Research question, found it. There's 3 of them at least. Surprise, surprise. Are there gender differences?
I guess we have to put it.
Well, I'm just like,
What's that?
so
H1,
basically they're just breaking it down to their categories here. Gender differences, team learning.
It's fine, all three. Arts. Arts.
Moving for.
Effort on what?
We're gonna mention these, man, she has.
Bunch of credits.
You said H1.
H1, H2.
Yes, sir.
All right, H1, H2.
Overall.
Or within subject variables.
Definitely learn
Well, there's EA.
We're gonna get done. It's gotta be done. That's more. That in 3 weeks, we're gonna completely what's okay, anyways, next. I know. What do you mean you're waiting on me? You're.
What are the within subject variables? Like the same, people
Well,
are
it's still good, it's just the.
So between subjects.
Between gender.
Sales promotion.
There's A. With these.
Do they go through different types of tool learning? Or do
I
they
don't
go through them?
Online and face to face.
That's the tool learning. The dependent variable is the effort.
Yes. Effort is.
Desire.
Right. What was the design of the study? Excuse me?
So
No,
this is kind of gives some information about what they're doing.
Online and face-to-face
Kind of
two
details on the high level.
gender is two factors.
yeah.
Well, first of all.
So you have two columns. Noticing, got some, got some.
Okay, look for the same.
And basically, just between some gender, so.
It's not gonna-
Yeah,
They couldn't find one more college student.
it's back, it's random, yeah. Completely random.
Also have a sensitivity as a very low. But that has, 1, 2, 3.
This one, you won't be gonna be dependent, I guess.
What was we do?
This over here, you know, it's like, word of mouth, yeah.
Yeah, it's multivariate, I didn't know this.
Well, you do,
You won't be.
2 by 2, 2 by 5, right? Because you would look at their gender versus
Samples.
community, gender versus. Policy, doing the job.
Should be a two-way between. Yeah.
That's
That's
it.
what I- well, that's what
Explain all these, is there a lot of them?
I only got one so far. So this is for course invoice format and gender.
Yeah.
So that would be, is F1, comma, 75, 4, P is equal to 001. Yeah.
You're supposed to do the P value as what it's equal to, but then it's less than your significance. Does it matter?
They measure it. Yeah.
So you want.
I mean, you're
what amount?
supposed to be consistent, they kind of use that throughout, but some will report it at the lowest level that it would have been significant without really fixing
Questions
the
are,
value.
yeah, exactly. Yeah.
Right.
They do sometimes.
So what amount do you independent level?
It's gonna be dependent.
And then
Yes.
Well, wait a minute, you know, multivariate study, I'm ready to go off here.
I guess we
You
do.
can't figure if you're independent variable, it's multivariate, so you also need independent variable. Yeah, friendship.
I guess that.
Like, what amount's gonna be the high base? Then this is multivariate study. all that. Which I totally do. Let me see this. Okay.
It's a challenge for us.
Multivariate study, which means that it's the most independent variable. Yes. I got that wrong. Okay, good. I'm glad you corrected me. I'm not here.
you can, look at this.
Whenever we got it analyzed, and general model,
Univariate.
click on univariate, yeah,
Multivariate averages most of the variance.
right.
Yeah.
Gotcha. Okay, so, I'm right, so if you want to have.
Really dependent.
That means a friendship.
It's like, you know, it's-
What information are we?
So information value, entertainment value, friendship.
There's.
I've not seen.
We give you 5 more minutes.
Really?
Question four,
Oh, okay.
those are here. Right.
I think this is more detailed.
And then we go with that.
I have not.
Yeah, it's a-
I've not seen any posts.
Hey, what's
I have a statement of post logs, but I don't have any like backing it up.
It's a nice table. Gossip first. Nice. Maybe this one. Yeah, you see some.
Critical alpha is 0.01.
Yeah. Yes.
So I guess involved in then there's
So it's gonna be 1, 3, 1, 15.
No,
Two weeks.
Well, there's 5 moments, all of them, there's right now.
Conclusion of also was there is a significant difference between gender between gender
Should be two.
There's two for sure.
Gender and student. And then females.
So that would just make maybe 6 times. So,
Yeah.
right, so it's 2 levels as opposed to kind of possible.
Yeah.
But it's still 2 levels.
Yeah, which is probably more like.
Probably, yeah. Just have
You talk about the most of gospel.
Says defendant variable.
They also mentioned that they,
So the other internal variables are.
They're in T-tests on
Size.
face-to-face.
So there was a
yeah,
product involvement. Network size. Size strength.
I agree.
Where they take it.
But I agree with you. This is- Do you believe that?
Correlation.
Analysis. Procedure here. Bullying.
They would actually test that when they got there. They mentioned the assumption that. We don't have to check it, use that one program. Starts off, all this, they do something. Talks about how.
Yeah,
Yes.
They did a lot of
It's
it.
testing.
Also,
So that's just testing.
Conclusions and recommendations.
good on them.
There's going back on, where in which there is instructed.
Well, we don't know any of the assumptions.
This is one here. This is what we do.
Years, but,
It was also competitive.
And there was even. This will be number,
Yeah, I don't like
here. Number four. So now,
Sorry.
here. One.
Sure.
Equals to.
Hold on,
They don't have our work rate. Hey, and this is definitely something people can come state. Yep. Last two authors are definitely from state.
Okay.
But they're third and fourth authors, so.
There are multiple papers.
No, there's second. Only the first person from University of Texas. Texas is not bad. How does it look when you lose to the teams that just lost to everyone else? But you beat OU, like,
Hey, did you see that Tennessee game though?
no, I didn't see any games, so,
We beat Florida.
I saw that they beat Florida.
Okay, let's review these two. Okay, which group had student? Okay, just that one. Okay. So this one is in the Journal of Advanced Academics in 2011. And what was the research question for this study?
There was 3 of them.
3 of them, pretty explicitly stated. Yeah.
Yes.
Which ones of these were specific for ANOVA?
The first.
Just the first one really used ANOVA. The other ones were regression and some other analyses. So that's really the only one that I wanted you to focus on. Are there gender differences in student effort expenditure in online versus face-to-face courses? From that, we can kind of get what the factors are. What are the factors in this question? Gender,
their effort level, and well, that would be the comparable, but gender and then their face-to-face.
and online versus face-to-face. So the format. So kind of like the little example we were doing in class. And what is the dependent variable? Effort, student effort. And so it goes on to talk a lot, give a nice model there with some methods. It describes the people in the study. And here are the results specific for the first research question. And they again explicitly state we did a 2-way between subjects and ANOVA. Do you feel like that was appropriate for this study, this question? Yeah. And what did they test first? The interaction effect. And was it significant? It was significant. Here they have an alpha of 0.01, but they note the significance as 0.001. So we were talking about this, and I think it's best practices to pick an alpha and keep that alpha the whole time. But here, if you want to show the extent to which you are significant, in some ways you can modify that. But I would say it's not always best to say P equals, but to say P less than some value would be a recommendation there. So then, did they look at simple main effects as they should have? So this sentence says females reported more effort in the face-to-face course, and males put more effort into the online course. Does that sound like a simple main effect conclusion? Yeah, because we're talking about the specific levels of both of those factors at the same time. So they might not have given the actual statistics for it, but they did describe it, and here's the table that gives those different group means. Did they talk about assumptions? No, they didn't talk about assumptions. What about additional measures?
Yeah, measure of association.
Yeah, they do have this measure of association, eta squared. Did they talk about their limitations? Not a whole lot. How would you rate this article? And we just read one little piece of it. And that's really, for that 2x2, they talk about the interaction and all that. They're missing the assumptions and just talking about that. But otherwise, how would you rate it? B-ish. Pretty clear to understand.
And they have the research question really obvious. That helps to lead it.
Yeah. Denoting those research questions is really helpful. So, and I would agree with your evaluation. Comparing that to, you guys didn't read it, but the online gossipers, how was this article?
Hard.
Hard. I had to read this one several times to figure out what levels and what were they comparing, and they have a lot of factors going on here. Would you agree? Yeah. Okay. So this one is in cyber psychology, behavior, and social networking in 2013. And they mention some ANOVAs even in the abstract. Do they mention or explicitly state the research question? Yeah.
So there are 7 different questions.
They have a lot of questions. Let's see. They talk about the fundamental question, but there's a lot of different components. In this research question, do online gossipers promote brands? We know that the article is a lot more complicated than just gossipers, right?
Yeah.
So it's really nice to have your research questions specific to those levels like that first article was. This one doesn't break it down in terms of the questions, but it does have hypothesis 1, hypothesis 2, and hypothesis 3. Which of these were specific to the ANOVA?
H2 and H3.
H2 and H3. So here we see H2A. When the effects of tie strength and network size are both considered, gossipers rather than non-gossipers will be more willing. So from that, what are our factors? Tie strength, network size, and gossipers or non-gossipers. They have 3 factors. And what is the dependent variable? Their willingness, yeah. And they break this down. Which one is it? Let's see. Table 4 gives the tie level and the network size level, and then the gossiper, non-gossiper. And then how did they differentiate this low and high involvement? Did you get to that one?
That was something earlier today, like a pilot study.
Yeah. So it almost looked like from this table they did a 4-way study. But yeah, so they had done a study earlier and differentiated those. And so H2 is specific for high involvement, and HC is specific for the low involvement. Yeah. Okay, so let me see. Conclusions. A 3-way and a 2-way ANOVA. Would you say that those were the appropriate analyses for those? When you have that many factors that are all independent, then yeah. Here we see that a 3-way interaction was performed, and it shows that a main effect of propensity to gossip was significant. What does that mean to you?
That's H2A, right?
It's supposed to be H2A, yeah.
Gossipers more prone to participate in word of mouth compared to non-gossipers. So
Think about the words that they use there. If you're doing a 3-way ANOVA, what should you test first? Interaction.
yeah.
And here, what do they report? A main effect. So maybe the interaction wasn't significant,
So they give it-
and they jumped to the main effect. My thing was then H2B and C are also gossipers within ties and gossipers within networks. So it almost appears to me like maybe the interaction wasn't significant, and then they took that three-way and broke it into two-way interactions. I think is what they did here. But I'm not exactly sure about where this main effect came into play. But I agree, this one was kind of hard to read and to decipher. And I had to read it many, many times. They do the same thing with H3, specifically for the low involvement, that three-way, kind of break it down into sub two ways, et cetera, et cetera. Do they talk about assumptions? Yeah, they do. Where is that at? Oh, did I pass it? Oh, there it is. So they talk about Levine's test and the assumption was met. Do they talk about normality? I didn't see that one, but I did see Levine, so thumbs up on that. How would y'all grade this one? In terms, that's an interesting point. In terms of readability, it's not very good at all. Yeah.
So I would say like this get published.
It's just different articles, and sometimes, you know, if it's not a really quantitative, rich journal, then maybe the way that they report their statistics and stuff isn't by the books how we would like it. But if they have a good discussion and they're really good at articulating the results in terms of what are the implications in the discussion or something like that, sometimes you'll see really short results and then a good lengthy discussion. Sometimes that's what journals are more interested in than just the nuts and bolts of the statistics. Any questions about these? No? Okay. So there is a worksheet in the week 12 content. It's the interest data again. So interest in school and work for different age groups. But there were those additional factors of gender and something else that was on there. And so now we can use those for our factorial design. So that's what the worksheet is specific to, doing some of this in SPSS. So for the remaining time, you can just work on that and let me know if you have any questions. Okay? Good deal.